Hey guys, in this video we are dissecting the fretboard geometry using color to see the interval patterns. And here we're going to look at intervals 2 and flat 7 to see how you can play them up and down the instrument in different keys. But first, let me explain the underlying theory behind these intervals. Using the key of C, for example. In the key of C, intervals 2 and flat 7 are on either side of the tonic, interval 1. So C is the red square at the top, and 2 is the orange square, D, and flat 7 is the purple square, B flat. And both of these notes are squares because they're spaced at one whole step interval in each direction from the tonic. And since the tonic, interval 1 is a square, 2 on the right is a square, and flat 7 on the left is a square as well. Intervals 2 and flat 7 are known as the major second and minor seventh respectively. The major second, which is sometimes called the supertonic, super means above and tonic is a reference to interval 1. So the supertonic, interval 2, is above the tonic. The supertonic is in the tonic's major scale. It's also closely related to the perfect fifth note of this key, so it shares a certain affinity for the tonic. The minor seventh isn't in the major scale, but because it's closely related to the perfect 4, it also has a special bond with the tonic, interval 1. So because of these affinities, these notes are friends of the tonic. You'll often hear both of these intervals in a lot of music. The tonic, 1, supertonic, 2, and flat 7 are all part of a hexagon of whole step intervals. And because these notes are spaced at whole step intervals, you basically play them by pressing every other fret up the fretboard on different strings. They're spaced at whole step intervals, therefore every other fret. Again, looking at the key of C, and when you fade all of the other notes and focus just on these three intervals, 1, 2, and flat 7, you can see how they form this pattern on the fretboard. And when you condense the frets a bit so that they're evenly spaced, the fretboard turns into a kind of chessboard where you can see this pattern of notes as they rise and fall up the fretboard a little more easily. Okay, so let's play this pattern in the key of C, starting on the B flat, the flat 7 on the 6th string, 6th fret. And you'll notice that these intervals form kind of a happy, positive sound. Now I'm playing these intervals just rising up the strings like this, but as you start to get your bearings, you can navigate between these intervals in different ways on different frets and different strings. So for example, we could play this C note, interval 1, and go up 2 frets to the major second, or we could stay on the same fret and drop down 2 strings, and C goes down to D, major second, here. Or say we're starting on this C note here, we could go down 2 frets to the flat 7, minor 7th, or we could stay on the same fret and go up 2 strings to B flat up here. So there's different ways to move between these intervals, but once you get a feel for the way they're arranged on the fretboard, following simple symmetrical patterns, then you can really jump around as you get a feel for them. So speaking of getting a feel for them, let's play them in the key of G. So now we've rotated the interval 1, the tonic, to the red-orange circle, G, and A, orange-yellow circle, is major 2, and then purple-red, F, is the flat 7 note. So here we go. And then moving on to the key of D, where D is 1, the pattern sounds and looks like this. And then in the key of A, where the orange-yellow circle is 1, the pattern looks and sounds like this. And then after the key of A, we can play through all the other keys as well because, again, they all follow the same interval patterns. So there are basically 2 sets of hexagons. You have the squares that are all evenly spaced at whole step intervals, and all the circles that are spaced at whole step intervals. And these 2 hexagons interlock to form the 12 notes of the chromatic scale. Again, the colors reveal the simple geometric connections between keys based on the intervals they share. And in the next video, you'll see how this powerful symmetry extends to the intervals of flat 2 and 7 as well. So definitely check it out, and I will see you there.